Hello everyone, I welcome you all for SVK tutorials. Yes, I'm welcoming you all with a new topic. Today I'm discussing a topic on differential equations of higher order. So here just I have taken one example of a LCR circuit. For this LCR circuit, we can construct an higher order differential equation of the form L into d square I by dt square plus R into di by dt plus 1 over C I, which is equal to E dash of t. Now let us discuss higher order differential equation with constant coefficient. Higher order differential equations with constant coefficient. Let us see a differential equation of the form called a naught nth derivative of y with respect to x plus a1 n minus 1th derivative of y with respect to x plus so on etc. an minus 1 dy by dx plus an y equal to p of x, where a naught a1 an minus 1 an represents a constant coefficients of the given differential equation. Just we can recall the differential equation of the form called nth derivative, nth order derivative. So therefore that's why it is called as higher order differential equation. I have considered nth order differential equation in general. So I have defined here where a naught and a1, an are all constant is called a linear differential equations of nth order with constant coefficients. And we can rewrite this differential equation with an differential operator using an differential operator. Now we shall rewrite the above differential equation using standard notation called differential operator, where standard notation represents like this. Capital D can be written as d by dx, as y is depending on x here. That's why capital D is equal to d by dx. If y is depending on t, we will represent capital D as d by dt. Similarly, d square can be represented as d square y by d square by dx square. D power n can be represented as d power n divided by dx power n. So using these notation in the above equation, we can rewrite the above equation as follows. So a naught d power n, this can be written as a naught d power n plus a1 d power n minus 1 plus so on etc. an minus 1 d on plus an on y equal to phi of x. So in general, this expression can be written as it is. This term contains only terms of d with constant coefficient. So I can define that function as f of d on y equal to p of x. So here we can discuss two types of differential equation depending upon phi of x. If phi of x is equal to 0, then we name that equation as a homogeneous differential equation. That is of the form f of d on y equal to 0. If phi of x is not equal to 0, then we define f of d on y equal to phi of x as such d is called as non-homogeneous differential equation. Now let us first discuss how to find the solution of homogeneous differential equation. So when I consider f of d on y equal to 0, we are going to write an auxiliary equation. So from that auxiliary equation, I am going to get an roots called, it may be real roots. There are methods of roots we are going to find. So if the roots are real and different, then m is represented as, if the degree of that given equation, auxiliary equation is 2, we are going to get two roots. So therefore, if m is represented as m1 and m2, where m1 is not equal to m2, then we write the solution as y equal to c1 e power m1x plus c2 e power m2x. How we represent? Y equal to c1 e power m1x plus c2 e power m2x. So for example, if the roots are 1 comma 2, m1 is 1 and m2 is 2, just replace m1 by 1 here and m2 by 2. We are going to get the solution as y equal to c1 e power x plus c2 e power 2x. Similarly, if the roots having three roots 1 comma 2 comma 3, then the solution is y equal to c1 e power x plus c2 e power 2x plus c3 e power 3x. Okay, I think you all understood. for if the roots are 1 comma 2, then we can write it as c1 e power x plus c2 e power 2x. Similarly, if the roots are 1, 2, 3, we can also write it as c1 e power x plus c2 e power 2x plus c3 e power 3x. So next case, if I want to discuss the case 2, then if the roots may be real and same, that is m1 and m2 are equal, same roots. For example, 1 comma 1, 2 comma 2, such roots if we get, then the solution is represented as follows: y equal to c1 plus c2 x e power mx. How we represent? c1 plus c2 x e power mx. So in case of three repeated roots, the roots are if the degree of the equation is 3 and all the three roots are same, real and same, that is m1 is equal to m2 equal to m3, that these three values are equal to m, then we represent that solution as y equal to c1 plus c2x plus c3x square e power mx. How? c1 plus c2x plus c3x square e power mx. So for example, if the roots are minus 1 comma minus 1, then we can write the solution as y equal to c1 plus c2x e power minus x. Since the value of m is minus 1, just replace the m value as minus 1 here. We are going to get an solution as c1 plus c2x e power minus x. Similarly, if the roots are 1 by 2 comma 1 by 2, we can have the solution as y equal to c1 plus c2x e power x by 2. X by 2. My 1 by 2 times of x is nothing but x by 2. So if the roots are real with different and also same repeated roots, real 2 and 3 are different and 3 are same, then the solution is represented as y equal to c1 e power 2x. The type 1 case 1 and case 2 has been mixed here. c1 e power 2x plus c2 plus c3 x e power 3x. For different roots I have represented as c1 e power 2x, plus for same roots I have written as c2 plus c3x e power 3x. Now let us see case number 3. If the roots are complex roots, that is m plus or minus in, then the solution is represented as y equal to e power mx times of c1 cos nx plus c2 sin nx. So what is m here? Real part, and n is what? Imaginary part. So if we get an only imaginary part, that is another way of representing the solution. If we get both real and imaginary part, this is the way of representing the solution. We represent the solution for m plus or minus in as y equal to e power mx times of c1 cos nx plus c2 sin nx. For example, m equal to 1 comma m equal to 1 plus or minus 2i. Here, if I compare with the complex roots, m represents 1 here, n represents 2. Then the solution is given as y equal to e power 1x. Y equal to e power 1x times of c1 cos 2x plus c2 sin 2x. So as I told you that if we have only imaginary part, the solution is different. So if we have plus or minus in, then we write the solution as y equal to c1 cos nx plus c2 sin nx. For example, if the roots containing plus or minus 3i, then the solution is what? Can you guess? Is just y equal to c1 cos 3x plus c2 sin 3x. This is the way of finding the solution for homogeneous differential equation of the form what? F of d on y equal to 0. We are going to write an auxiliary equation. Then for that auxiliary equation, we are going to find the roots. The roots may be of these three cases. Case 1 is what? Real and different. Case 2 is what? Real and same. Case 3 is what? Complex roots. So memorizing these formula, we are going to have only three formula. Remembering these formulas, we are going to solve the problems. And before that, I am going to just give some examples for using all these three cases. Let us consider case number one, that is example number one. If m is 3, 4, as real, the roots are real and different, the solution is represented as y equal to c1 e power 3x plus c2 e power 4x. If the roots are minus 1, 2, minus 3, then the solution is represented as, which is also called as, this solution is also called as complementary solution. We also name this as complementary solution. So y equal to c1 e power minus x plus c2 e power 2x plus c3 e power minus 3x. If the roots are 2, 2, so by observing the roots, we can say that the roots are repeated. So we can go with type 2, case 2, that is c1 plus c2x e power 2x. If the roots are real, different and same, real, different and same. So 1 is different from minus 2, that's why it is different roots. Minus 2 and minus 2 are same roots, that's why we have same roots. So here we have 3 roots, then the solution can be represented as c1 e power x plus c2 plus c3x e power minus 2x. If the roots are m plus or m equal to 1 by 2 plus root 3 by 2 and 1 by 2 minus root 3 by 2, here real and different roots we have. So therefore I can write the solution as y equal to c1. This is one root. It is one root, 1 by 2 plus root 3 by 2, and another root is 1 by 2 minus root 3 by 2. Both are different roots. Therefore, I can represent it as c1 e power 1 by 2 times 1 by 2 plus root 3 by 2x plus c2 e power 1 by 2 minus root 3 by 2x. If we have the root as root 3 and root 5, guess the answer. Okay, try by yourself. If the roots are 2 plus or minus 3i, then y equal to e power 2x. Since we have both real part and imaginary part here, so we can represent the root as e power, solution as e power 2x times of c1 cos 3x plus c2 sin 3x. If the roots are 1 plus or minus I, then we can write the solution as y equal to e power x times of c1 cos x plus c2 sin x. The roots are only imaginary parts. Look at here. We are having only imaginary part plus or minus 2i. Then the solution is c1 cos 2x plus c2 sin 2x. If the roots are plus or minus root 3i, here the imaginary part is root 3. Imaginary part is what? Root 3. Therefore, the solution is c1 cos root 3x plus c2 sin root 3x. The solution is 1, 3. If the roots are 1, 3, 3, 1 plus or minus I. So, all the combination I have taken real, different, same and complex roots. So the solution is y equal to c1 e power x plus, for repeated roots, c2 plus c3x e power 3x for complex roots, plus e power x times of c4 cos x plus c5 sin x. Once again I will tell you, if the roots are 1, 3, 3, here 1 and 3 are different, that's why we have represent c1 e power x plus c2 plus c3x. Since 3, 3 is repeated roots, therefore it is c2 plus c3x e power 3x, and 1 plus or minus I is complex roots. We represent it as e power x c4 cos x plus c5 sin x. Now, if the roots are of the form, see the difference here. Here also you are having real and different, but the same problem I have considered with complex number. Same problem with complex number. So see the difference here. See the difference of writing between this problem and this problem. So the solution are different, totally different. Don't get confused and don't mess up with this. Okay, be careful. If you get I, treat that as complex number. So when you are not having any I number here, so that represents only real number. So therefore, as we got I here, this represents complex number. The solution is what for this? It is e power x by 2 times of c1 cos root 3 by 2x plus c2 sin root 3 by 2x. I think you all got some conclusion regarding how to write the solution for homogeneous solution, homogeneous D. Okay, now we shall solve some problems on homogeneous differential equation. Let us consider problem number 1. The given problem is solve d square y by dx square minus dy by dx minus 6y equal to 0. So the problem is of the form f of d on y equal to 0. So that's why it is called as homogeneous differential equation. So step number 1 to solve this is we are going to rewrite this solution as in terms of auxiliary equation. We rewrite this as instead of d square. D square is what? D square by dx square, right? Instead of d square, I am going to write it as m square. Instead of capital D, I will write it as m, and the constant will be retained as. So m square minus m minus 6 equal to 0. By using your calculator, we can solve this equation and we can get an root. If you have any difficulty in solving this, see my previous video. I have solved for cubic equation and quadratic equation, how to find the roots of such equation I have explained you. So you can go through that video and then you can come to know what is the roots of the given equation. Here for the roots, for the given equation is m is 3 comma minus 2. So by looking at the roots, I can decide that the roots are real and different. Therefore, I can write the solution as c1 e power 3x plus c2 e power minus 2x. If I go with next problem, d square y by dx square plus 3 dy by dx plus 2y equal to 0. Then I can first thing what we should write. We should write auxiliary equation. Any guesses? Yes. How to write the auxiliary equation? D square is replaced by m square plus 3d is replaced by m. So 3m plus 2 equal to 0. So this is the auxiliary equation, m square plus 3m plus 2 equal to 0. Then solving this equation by using your calculator, you're going to get the roots are minus 1 comma minus 2. Observing on the roots, I can say that the roots are different. So the solution is given by y equal to c1 e power minus x plus c2 e power minus 2x. We'll go with next problem. D square y by dx square plus 6 dy by dx plus 9y equal to 0. So another way of giving the problem is d plus 3 whole square on y equal to 0, or another way of giving the problem is d square plus 3d plus 2 on y equal to 0. You should have all these awareness of having the differential equation. All these three types are differential equation. So they can give directly d plus 3 the whole square on y equal to 0. Directly you can write the auxiliary equation as m plus 3 the whole square equal to 0. M plus 3 the whole square equal to 0. Or for this equation, m square plus 3m plus 2 equal to 0. So writing the auxiliary equation and finding the roots for that equation, we are going to get repeated roots, that is minus 3 comma minus 3. What is the roots? Minus 3 comma minus 3. So once you came to know that the roots are real and repeated, we can write the solution as y equal to c1 plus c2x e power minus 3x. c1 plus c2x e power minus 3x, as the roots are repeated roots. Yeah, we shall go for more problems. I have considered d square plus 16 on y equal to 0, or they can also give the problem as d square y by dx square plus 16 y equal to 0. So then the auxiliary equation can be written as m square plus 16 equal to 0. Then solving this equation, while solving in your calculator, you can put the values of coefficients of m as 1, 1, 0, 16, 1, 0, 16 as the while substituting in your calculator. Then the solution will be, the roots of that equation will be plus or minus 4i. Then we can write the solution as it is only imaginary part we have. So we can write the solution as c1 cos 4x plus c2 sin 4x. This is the way of solving the problem of the given equation. Next, if I go with next problem, similarly I have taken, instead of d square plus 16, I have taken d square minus 36. Is of the form m square minus 36. The roots of this equation is 6 minus 6. the roots are real and different. Therefore, the solution is y equal to c1 e power 6x plus c2 e power minus 6x. So you should know the difference of these two problems. Here, while typing in your calculator, you are going to type the coefficient of m as 1, 0, 16. In this case, you are going to type 0 minus 36. So that's why you are going to get different roots here. Here you are going to get imaginary roots. So go with the next problem. D square minus d on y equal to 0. This is very important problem. So the auxiliary equation is m square minus m equal to 0. So without calculator, you can solve this problem by taking m as common. You are going to get the factors as m into m minus 1 equal to 0. Therefore, one root will be 0 by equating these two values to 0. One root will be 0, another root will be 1. So therefore, the roots of this equation is 0, 1. Therefore, the solution is y equal to c1 e power 0x here. E power 0x, a real value raised to the power 0 is 1. That's why it is just c1 into 1 is what? C1. I have written c1 plus c2 e power 1x. It is e power x. So when you come to the another problem, it is also very important. They can also ask the problem like this. Find the roots of the equation for the given d of the form d square plus or d square times of d plus 1 on y, or d cube plus d square on y equal to 0. When they give, you can directly write down m square, the auxiliary equation, as m square times of m plus 1. So therefore, you'll get the solution as the roots as m equal to 0, 0, repeated 0 roots, and another root as m equal to minus 1. So m square times of m plus 1 equal to 0. Therefore, m square equal to 0 and m plus 1 equal to 0. From this, as m square is repeated here, m square, m into m we can write. So therefore, m equal to 0, 0 we are going to have, and another root as m equal to minus 1. As the degree of this equation is d cube, you should have 3 roots. Therefore, write down the roots in general as 0, 0, minus 1. As 0, 0 are repeated roots, you will write the solution as c1 plus c2x e power 0x is 1. So that's why we are left out with c1 plus c2x plus, therefore, different roots c3 e power minus x. So make this as star mark. This problem is very important. When they give in your examination, be careful, and while solving the roots of that equation and writing the solution for such types of equation. We go for next problem. So I have considered degree 4 here. 4 d power 4 minus 8 d cube minus 7 d square plus 11 d plus 6 on y equal to 3. So as you came to know, the previous problems what I have considered is of degree 2 and degree 3. Here in this problem I have considered degree 4. If you write the auxiliary equation will be 4 m power 4 minus 8 m cube minus 7 m square plus 11 d plus 6 on equal to 0. So how to solve such type of when we name this type of equation as biquadratic equation. So when you get biquadratic equation, how to solve this equation? We are going to find the roots by inspection method. By giving suitable value for m, we are going to get an root. By using that root, we are going with synthetic division to find the remaining roots. So use your calculator to find out the one root of this equation. We are going to type the equation as of this form. In your calculator, you can type like this: 4x power 4 minus 8x cube minus 7x square plus 11x equal to plus 11x plus 6. Then press calc. You are going to get it will ask for the value of x. Give x equal to 1, press equal to. If the value is equal to 0, then that will be the root. If it is not, go for again calc. Give x equal to minus 1, press equal to. If you get 0, then that will be the solution. for the root, that will be the roots of that equation. If it is not 0, go for another value called 2. Likewise, you go for -2 until unless go by trial and error method by giving alternate values 1, -1, 2, -2, 3, minus, like this. So for this problem, for x equal to -1, you are going to get a 0 as the solution. That is a root for one root what we are going to get. Then using that root, I'm going with synthetic division. So by inspection method, we have got m equal to -1 as a root. So by synthetic division, I will go with reducing degree 4 equation to degree 3 equation. I will reduce the equation degree 4 to degree 3. How it is possible? Write down the root, whatever the root we got here in the left hand side, m equal to -1. So take the division here. So how to write these values means these values came with the given expression called degree 4. The coefficients of m I am writing. M power 4 coefficient is 4, m cube coefficient is -8, m square coefficient is -7, m coefficient is 11, the constant term is 6. This is what I have written. 4, -8, -7, 11 and 6. So start with 0, add these two values, 4 plus 0. 4 plus 0 is what? 4. So then multiply this value 4 with -1. We are going to get -4. 4 into -1 is -4. Write down that value -4 here and add these two values. We are going to get -12. Multiply with -1 again. We are going to get +12. Add these two values. We are going to get 5. Multiply with -1. 5 into -1 -5. Write down that. So add these two values. We are going to get 6. 6 into -6. We are going to get -6. Add these two values. We are going to get 0. So now multiply this values by from starting with the degree 3 called m cube. So we can rewrite this expression as 4m cube minus 12m square plus 5m plus 6 equal to 0. So using your calculator, we can find the roots of this equation. So that is, we are getting the roots as -1 by 2, comma 1, comma 2, comma 3 by 2. The roots of this degree 3 is what? -1 by 2, 2, 3 by 2. So if you want, if you are not understood how to find the solution, you can go verify the previous video. I have explained in depth how to find the roots of cubic equation. So after getting the cubic equation roots here, so observe here one thing, the given differential equation contains 4, degree 4. So you should have 4 roots. Therefore, don't forget the root what we got by inspection. So we are going to write in general. Therefore, the roots of the given equation is -1, -1 by 2, 2, 3 by 2. Therefore, the solution is what? Y equal to c1 e power minus x plus c2 e power minus x by 2 plus c3 e power 2x plus c4 e power 3x by 2. So this is the solution of the given differential equation. So similarly, you can do if you get degree 4. So go through this procedure and solve plenty of problems like this. Shall go on to next problem. I've considered d power 4 plus 64 on y. So it is quite different from previous problem. As I told you, degree 4 can be solved like that. But as there is no terms other than the degree 4 and constant, we'll solve in another way by using the formula called a plus b the whole square equal to a square plus b square plus 2ab. To solve this problem, let us know first what is a plus b the whole square, a square plus b square plus 2ab. Then from this I can get a square plus b square. I will write down a square plus b square as a plus b the whole square minus 2ab. Then I will come to the actual problem. M power 4 can be written as m square the whole square. 64 can be written as 8 square. Comparing this expression with a square plus b square, here I can have a value as m square, b value as 8. Applying this formula here in place of a, instead of a square plus b square, I can rewrite the problem as m square plus 8 the whole square minus 2 times of m square into 8 equal to 0. Just I have substituted a, b value, that's all here. Just I have substituted a, b value. So therefore I got the expression as m square plus 8 the whole square Here 2 8s are 16. 16 is a perfect square. So I can write that as 4 square. So 4 square m square can be written as 4m the whole square. Did you got? How I have written 2 into 8 is 16. 16 is a perfect square that can be written as 4 square. So you are left out with 4 square m square. 4 square m square can be written as 4m whole square. So the problem has been reduced to a square minus b square equal to 0. So now a square minus b square is a standard form. We can write that in terms of factor called a plus b into a minus b. So therefore, substituting the value a value as m square plus 8 and b value as 4m, I'm going to get m square plus 8 plus 4m and another factor as m square plus 8 minus 4m equal to 0. So considering one of the quadratic equation, so I'm solving this in using your calculator. Here, while typing in your calculator, be careful. The coefficient of m square is 1. The coefficient of m is 4 here and constant term is 8. If you solve this, you're going to get the root as minus 2 plus or minus 2i. And for this, you're going to get 2 plus or minus 2i. So therefore, these are the required roots of the given equation. As we have degree 4 here, so you are going to get 4 roots here plus minus 2 roots. Again here plus minus 2. So 2 plus 2, 4 roots you have got. So the final solution of this given differential equation is y equal to e power minus 2x times of c1 cos 2x plus c2 sin 2x plus e power 2x times of c3 cos 2x plus c4 sin 2x. Similarly, I have considered one more problem. Instead of 64, I have considered 4 here. So go through this problem. See here, just instead of m power 4, I have written m square the whole square. 4 can be written as 2 square. Here you may ask me one question, that if we get 5, what to do? You can write that 5 as root 5 the whole square. Make sure that root 5 the whole square. So then a value is m square, b value is 2, then substitute that values. You're going to get the form a square minus b square. So you know that a square minus b square can be written as two factors, sum of two factors, sum and subtraction of two factors called a plus b into a minus b. So by using that, we are going to get the roots as minus 1 plus or minus I and 1 plus or minus I are the required roots. Then we can write the solution as follows. So I think you all understood whatever we have solved the problems here. If you are not understood, you can put a comment in my chat box. You can write a comment, and I will give a conclusion for your doubts. And those who are not subscribed to my channel, I request you to subscribe to my channel. Thank you all.